Okay, thank you to those of you that have already joined us this afternoon. We'll just wait a minute or two longer for some people that we're expecting, and then we'll get on with the presentation. But thanks for joining to those of you that have already done so, and I'll do some formal introductions in just a moment. Thank you to those of you that have just joined us. We're just waiting a moment or two longer before starting for some more people that we're expecting this afternoon, or this evening in the case of some of you. Okay, I think we're good to go. One or two more still going to join later, but they can catch up when we get started. So good afternoon, everyone, and thank you for registering for this webinar, where we're going to present and demonstrate IntelliTUNE, our auto-tunable combining system. Now, you've all joined in listen-only mode, so your microphones are muted, so please use the questions pane on your screen to signal if you're having any issues with the presentation. My name's Kelvin Law. I'm Sinclair's Director of Sales for the EMEA region, and my colleague Stefan Lavriv will be making the main presentation, and I'll introduce him shortly. Now, I'm sure most of you will know at least a little of Sinclair's long history in the radio communications industry, so I won't say too much about that. We were founded in 1951 by Dr. George Sinclair, and we've built an industry-leading reputation for high quality and reliable antennas and RF conditioning products that function well in extreme environments. And we've now added a range of auto-tuning combiners to our portfolio, which are the subject of today's presentation. So to briefly introduce Stefan, he was born in Sarajevo, the former Yugoslavia, which is today's Bosnia and Herzegovina, and built his first antenna at the age of 12 in 1972 and an AM transmitter 2 years later. Stefan completed his engineering degree at the University of Sarajevo with a major in radio communications and started his telecom career in 1986 working on telemetry and two-way radio systems for the gas and mining industry in Yugoslavia. He then immigrated to Canada in 1995 and worked mainly for cellular operators across the world before joining us in 2019. So after describing our IntelliTUNE Auto-Tunable Combiner, Stefan will give a live demonstration of the system, followed by an opportunity for you to ask questions. So over to you, Stefan.
Good afternoon, everybody. Thank you for joining my webinar, and we will talk about auto-tuning combiner, which combines two or more transmitters to one antenna. We will talk about features, what this auto-tuning combiner does and how it does. We will talk about where to use such kind of device, a little bit about installation and setup, and on the end I will show you how this device actually works. I have here next to me one demo setup. We put a 3-channel combiner, we put 3 transmitter as well, and I will change the frequency so you can see live how each auto-tuning feature works. To start with, let's talk about how it looks. This is the main unit, or main unit, which contains 2 cans. We start with 2 cans, and those 2 cans are connected through the isolators toward antennas. That can actually, what it does, there is a motor over here which will move plunger inside the cavities, and that way it will make to resonate on certain frequency. The auto-tuning combiner do analog to digital conversion of standing wave ratio measurement, and according to the algorithm, it performs tuning. So how that tuning works is, this is an interface which you will see yourself a little bit later, but in this case we have 2 channels, and we standing wave ratio on first and second channels. Those are 2 frequencies we are introducing to the system, And this is a report, what is the standing wave ratio, what is the frequency which is inside, and what is the power inside. You can always disable the port if you don't need it. But if I change the frequency, like on this slide, immediately nothing happens, since it needs the hysteresis and a few measurements along to happen before the tuning it starts. So this is very important for you. If you lose the power or turn off the combiner, it will remain in the position you left it. You don't need the power to work, although you need the power to change or deliver the alarm. So if we, after maybe second and start tuning process, as you see, return loss is changing toward the second frequency. In mid-time, I change another frequency on another channel to different frequencies. So now both has to do in the same time, which is tricky for a machine to do it, but it will do it. So it is a measuring standing wave ratio. Here is 4, here is 1/2.3, so it's not good. It will do iteration, and in a period of time about 5 to 20 seconds, depends of the jump of the frequency, it will tune exactly where it's supposed to be. And then, as you can see on the left, here it says tuning, system is tuning, and it's tuning on both channels separately, independently. On the end, this is the end situation. The two channels now, our system is tuned, and every channel has a green highlight, and now the frequency is 361.000, and the new frequency on the channel 2 is 361.151 megahertz. So we have a power of 5.2 watts on the second channel and 7.4 watts on the first channel. And the return loss is neg 15 dB on the channel 1 and 16 on channel 2. So this is a already tuned system. So going further down to menus, what is available over there, it will be the report which you did see already, so you know about this. But there is another parking solution, since we are selling the system in 2-channel increment. So you can buy 2, 4, 6, 8. But if you are having, let's say, 3 channels, what you do, you have to buy 4 and then use only 3. What will happen to the fourth one? The fourth one has to be set to the park position, and it won't be considered, and it won't be alarm performing. That will be for your future expansion if you add 4th channel, or it can be spare one in a case that the one of the system needs to be changed, or you may bring it to another location as well. This is upgradable anytime. You can take it from one location to any another location. So this system gives you a little window which shows you as well what is the standing wave ratio on your system. And this is the system configuration, which you can also add alarming. So alarm can be generated, sent via email, SMS, as required, as defined here. So you can send yourself SMS that SWR is bad on all channels. That means something is wrong with your antenna, or with the transmitter is not transmitting. So you may configure it many different ways, and you can monitor it many different ways. I did on my mobile phone. It works same as this tablet, or network operations center may also get incorporated into their alarming system, so they know that one of the radio is not functioning or is not functioning properly, or antenna system is not functioning properly. You can monitor input and output of your combiner and get all required information. So to get into installation and how it actually works, I will turn around the system. So this is how it looks from the back. We were talking about those motors which push the plunger up and down. Those 2 motors are controlled with this board here. And there is an input connector here and here through the isolator, which prevents any type of malfunctioning to affect your radios. Your radios are 100% protected against, even if you disconnect this cable over here, it will still, your radios won't even feel it. Short or open circuit works just fine. So how to connect two radios? You buy one, and you have to put another two channels. So you need to add this cable and this cable. That's all. So adding these two cables, you actually perform daisy chaining the boards. And this board is much simpler if you buy expansion unit. So one board is controlling both units. That way you save some money. And if you need a three sets or 6 channel, then you need to buy. This is just a LAN Cat5 cable, nothing special, few dollars. And then you add as well these T jumpers you can buy from us, or you can buy it anywhere else, and combine all those 3 units in one antenna. I can show you schematically how that looks alike. So this is schematics. As you can see on the schematic, we have a 4 channel unit, which monitors input of each channel separately and monitors antenna port. And that controller will be easily to upgrade, adding another. Now you have 6 channel, and combining those T splitter, you combine it to one antenna. This TJ style cavity is a very good performance, very high Q, more than 6,000 Q, which is very high even for theoretical, but for practical purposes, it is pretty tall can. For VHF, it goes all the way to almost meter height. Regarding expandable, yes, it is expandable. As I explained a few minutes ago, you can always add additional unit without controller, or you can take all this together and bring it to another place and put your antenna here. You move it to another location if necessary. And same reporting is this as it was before. So we are selling 2 options of this structure. This is 2-channel primary combiner, which I mentioned before. This is expandable, and there is 4-channel already expanded inside. So you don't need, if you need 4-channel to combine the 4 transmitter, it can go very easily there. Regarding the power, you can put the transmitters from 1 watt up to 150 watts without any concerns. It can handle that kind of power. Regarding the frequencies, we have models TGA221, that's our VHF models, works from 132 to 174 megahertz. UHF models, which goes from 350 to 512, and then IDEN model as well, 851, 869, and 700, 900 megahertz are in now final steps of development. They will get into mass production very soon. Those frequency band covers all European frequency and all North American frequency without any issues. So we don't have a separate models for Europe or for Asia or for Australia in that matter. All bands are covered that way. When you are ordering TGA, you have different frequency bands which you have to specify which you need, and then we can arrange that very easily, which model. That's for example, UHF model 3212-1 or -2, depends of your band which you want to cover, or your transmitter are working on it. So that's as I said, very easily customizable and very good for situation where you need to quickly change a frequency and quickly expand or add more channels as more services join. I will talk a little bit later about it. So this is how the unit looks like from the installation point of view. Here is a power off on switch. That is the only switch you have on the front, and on the back are connection, which I will show you in a few minutes as well. It's very rugged. It goes up to minus 50 degrees. So we are testing that unit here in Canada. And if it works in Canada, North Canadian, where the snow always stays, then it will work everywhere else. So for that reason, the best utilization for this kind of device is this kind of storage. So when you have event, as on the first picture, where you need your safety or maintenance people to get involved as a subcontractors, or you bring more different agencies join together, you can always add them into your system on the same antenna if they're on the same band, or if you have multi-band antenna, works fine too. Same applies in some disaster situation when you need to quickly deploy new site, which will be temporary location in case of flooding, fire, or crash of the site. As you can see here, the site, the antenna tower broke down. So they put a new temporary tower like this. You can always add or change or reconfigure your system accordingly. No problem. You can even mix VHF and UHF. They are totally independent. They look different. The cans are smaller for VHF and even smaller for higher frequency you go, but the format is the same, so they fit the same rack and they can be mixed easily. As you can see here, this is a typical application where you have your receiver path or receiver antenna on the top. This is UHF configuration. And then you have your TX controller controlling 2 units, controlling everything. You need a 55 dB isolation, but TX RX antenna, which is about 5 meters, between 4 and 5 meters to be more precise. Let's say 5 meters between top of TX antenna and bottom of RX antenna, and it will provide isolation between TX noise less than negative 85 dB of isolation, and noise influence of any TXs to any RX frequency. We have a separate units which is in RX part. You can buy it separately, and it has filtering on both sides. This filter can be 1 megahertz, 2 megahertz, wide, even 2.5 megahertz. I did see those. Goes up to 5, but there is no purpose. If you have a so high, then your TX-RX separation has to be way more than 5 megahertz. And UHF is 5 megahertz, pointless. 1 and 2 are most common use. This amplifier compensate losses in insertion loss of the both filters and the splitter loss, which is in 4-way, it's about 7 dB, let's say 7 to 8 dB. You may put more radios. If you put 8-way dB splitter, then you will lose 10 dB altogether. So this amplifier will be adjustable gain, so you can always have a, let's say, plus 1 here. There is another model which goes on the top of the tower right here, and then you compensate losses in the cables if your cable is introducing too much of noise. Now, I mentioned that you can sharing same unit. It's very easily, it's not necessary always to have a unit. We have here 2 radios. So if you don't need this unit, you can always disconnect, and you don't need this radio to bring it to somewhere else. You can always disconnect that, put antenna directly, and bring this unit and the combiner to another location and put it together, and it will start performing very well. It will auto-tune again. And when you disconnect the power or NRF, it will measure no RF, then it will go in a park position. And from there, it will auto-tune again as soon as it sense the presence of RF energy. So here is a little bit demonstration how you install it, installation and setup. So we will have a better look from the back, since I was describing the back, but I never didn't introduce how that actually looks. So here it is. We have a transmitter input, one channel, so the TX2 and TX1. They are here together with isolators, which prevents damaging of the radio by any kind of damage which may happen here or on an antenna port. No matter what, your radios are secure. Here is a connector for DC. So we have DC input here with the controllers and LEDs. Here is a LED which shows the status. Then it comes a LAN cable, and then the cable which is actually kind of USB serial port, which connects to the next one above or one below. So that's the reason why you have two connectors, one to connect the next one and one to connect to the previous one. If this is a main, then it will go only one cable to the next, and then from that next it will go from this cable on the top, it will go to the next again. So to show you how that actually looks, I will go back to next slide to my presentation. This is how the port looks. It's very simple. Inherent port, you can talk to the unit via USB, we put that as well. LED indicator with different colors, with different blinking. Here you set up, is it this primary or secondary? This is good case if you need to use your primary as a secondary. In that case, you don't have any secondary, but you have primary. So you just flip the switch and it will become secondary, and then you can daisy chain them as before. We have here a push button for factory reset and network reset regarding IP addresses, and if you need to reconfigure and start configuration again. And this is the database bus which goes up and down, down the chain. That would be all. It's very simple device, and I thank you very much for listening, and I'm open to the questions before we start a live presentation, which will be in a few seconds.
Yeah, so if anybody would like to ask a question, please use your questions panel on your screen, and we'll do our best to answer it. Thank you.
I don't see any questions yet.
No, I think you've explained it well enough, Stefan. Okay,
so now,
so why don't you? Sorry,
now you can see. Yeah. Yes, I'm showing now that interface which I showed in presentation, but this is a live interface. It is showing a unit which is just next to me. I will show you with my webcam. It's right there. So that's a VHF unit, which has 3 Kenwood radios mounted on the plate. I use this plate to mount them, and then connected to the 3 cans on the back. And here is a network. So I added also push to talk. As you may notice, there is no microphones on this unit. We don't have anybody to talk to, but we need radios RF to start working. So my push to talk are those 3. If I press any of those, you can see that it will start working on it. Okay, let's do any 2. Let's say 2. As you can see, it adjusted SWR in less than 5 seconds. Why is that? Because I already tested. So if I do the change of frequency, it will take a little bit longer. It won't be so fast. So let's leave that alone, put it back, no transmission anymore, and then go to the radio number 2 and change the frequency to another channel. And do the same. So it will take longer. And look how longer it takes. Yeah, it takes about 1 second, less than 1 second longer to adjust, since I just changed the frequency for 500 kilohertz. It's not too much. Let's do the rest, put them to work. As you can see, all 3 channels now are adjusted. And then you can go here, system info. As I was talking about, we have a voltage, power supply voltage here. I hope you see my mouse. Do you see my mouse? And you have here temperature in Celsius and Fahrenheit, and bus voltage here. And you can always adjust here what is your site name. So in a report of alarm, that site name will pop up. That site name here is Montreal, due to last location where this was installed in Montreal. It says Montreal. It has MAC address, firmware version, software version as well. If you scroll down, you will see that that all 3 motors are active. We can always, as Jan mentioned before, you can always change it, turn it off. And then you have log history, any errors happening before. Here is just restarting the network, changing IP addresses and all that. If you go to the network, you can configure your subnet mask, IP address, gateway, anything necessary to have a good network connectivity and a right format of reporting. So system configuration is this screen, which shows you which VSW arm it has to be achieved to threshold alarm. Here is 1.7 on all 3 cavities. You can change that, or you can go along with your specification of your antenna and do it differently if required. Now I have these beeps on my transmitters are transmitting too long, and then Kenwood is doing alarming me that I'm talking too long, and those beeps shows up if I don't turn off my transmitter on time. It has about 1 minute timer there. So as you can see, cavity enable is enabling the cavity to function or to be reported at all. So that's the case when you have 3, like here, you have 4th one should be disabled, but we didn't install the 4th one altogether. So there is no, here would be 4th one if you buy it in a rack mount, but this is not a rack mount. That's why it is as it is. So the fast you can here put how fast the motor will work, and will move the plunger in and out, and that faster you go, it is better to achieve, but it has disadvantages. If you go too fast, then it will miss. It will turn too far, then it has to go back and forward. If you use the fast one, it's good. It is good, but it has its own deficiencies. Let's say that's like everything else. It's tuning too fast, then it goes over that frequency and stop behind that frequency. Then it has to return and do more iteration, but it will be faster, right? So we have here a factory configuration, which user don't need to worry too much. And then you have here users. You can put several levels of users, which can be viewer, you can be service user or system user. System user is the guy who can do anything to this device. Viewer just can monitor what's happening, but he can't change anything. And service, of course, can do several changes, but not all the changes, like, for example, how deep the plunger will go inside. The service user don't need to do that. That will be done in factory while adjusting. And that would be about it. I did go to the all all menus here, you may turn on to these shortcuts, which gives you can shut it down, you can restart it, you can halt it if required due to change live. So all these components can be changed live. That means you don't need to shut down the system to add 2 more channels or to change 2 more channels. They can be totally independently added. That's very important when you are doing emergency services. You can't just stop the tower working. It's impossible to do. Service has to go on, and you just add more features or more channels, or change the alarming level, for example, from 1.7 as I have here to 3 or 2 or whatever you might be, up to your liking. That would be all regarding the demonstration. I demonstrate how it works with these radios. This is the only connection you need, 1 LAN cable to our network. I'm using company LAN, and here are the cavities deep inside, 3 VHF cavities. That would be all. If you have another question, feel free to ask.
Yeah, Stefan, I just want to put a couple of points there. You said a LAN connection to our network. That's what you're using today, but of course for the customer, they will connect to their own network. It's not tied to us.
They can do it. Yes. It is largely configurable to all kind of security and firewalls, and all that can be configured very easily on that network. SNMP configuration. Here you have all kind of IP, could be fixed, could be automatic, could be interrupted. All these features are here available for network administrator to configure as customer like and need.
That's great. Thank you for that. And we do have a couple of questions.
Yeah.
One is what is the insertion loss? Do we have an answer to that?
It should be about 1.5 dB.
Okay.
1.5 dB. For this unit, which the insertion loss mostly depends of how close the frequencies are. As closer the frequencies are, the insertion loss has to be higher to eliminate influence of the second channel to another receiver. So closer you get, more insertion loss you get. This is 1.5 is about 150 kilohertz channel to channel.
Yeah, which leads very neatly into a second question. We've got further questions coming in now. The second question is, what is the minimum channel spacing? And of course, that will be different between VHF and UHF.
Yes,
that's 150 for UHF, correct? 200 for VHF?
Yes.
Yeah. Yes. Okay. So just to restate that, then typically 150 for VHF, for UHF, and 200 kilohertz for VHF, typically.
Yes.
Is that correct? Yeah. Okay. Thank you. And we've got another question here. Let's see. Just bear with me a second, please. I'm having trouble finding that question. There is a question from Lindsay there. Let's just see if I can see that question. For some reason, I'm not seeing the question, but there is a question. Lynette, are you still online? If you are, can you see if you can pull up Lindsay's question? I can't seem to expand the question for some reason.
I see only 2 questions.
Oh, no, I've got it now. Yeah, okay, I've got it, yes. So the other question is from someone who wasn't able to join at the start, is for the maximum number of radios that can be connected. No, Stefan actually showed at least 6 radios.
Yes, I showed the 6, but could be more. No, there is not too much of difference.
But what's the
steps of 2? 8. I didn't see any system bigger than 8. Although I did see for some Saudi customer, they have 12 channels per antenna.
Right, okay, but typically we'd expect up to 8. And as Stefan's mentioned, we build these up in modules of 2. So if you have an odd number of channels, what we do is we can park or deactivate one of the channels, so you can have that as a spare in the future. Okay, any more questions from anybody else? Okay, for you, Lindsay, we are recording this webinar, so I'll make sure that you get a link to the video when we've published it, so that you can catch up, as it were.
I would like to mention on the end that this kind of combiner can be always added to distributed antenna system for in-building coverage as well, for industrial application. It's not just the tower. I was talking about tower. It's not always the tower. It can be DAS as well. There is no difference regarding where the signal goes, in building or outside the building.
Thank you for that. Okay, we've got another question now. Okay, oh, that's a thank you. Okay, yeah, well, I'll say thank you as well. Okay, so just one last opportunity if anybody else has got any questions. Otherwise, we'll wrap it up. Okay, yeah, well, thank you very much, everyone, for your attention. I hope you found it an interesting product. We think it's got lots of applications, and you know where to find us. So please get in touch if we can give you any more information or a quotation or anything like that. Okay, I think we can wrap it up. Thanks again, and thanks to Stefan.
Thank you very much. Thank you very much for listening.
Thanks,
Have
thanks
a
to
good
Lee
day.
in the background. Cheers, bye.
Bye-bye.